Thanks for watching this video. I want to do a quick demonstration on how uploading a website will work, how uploading a website would work on a peer-to-peer browser. Specifically, I'm using the hybrid browser, but this will also work on the aggregate browser. Essentially, what we're going to be doing is uploading a single HTML file. Now that sounds very simple, and it is, but I want to talk about it, and I want to show something about it that's going to be very important. So first, I just want to talk about, we need to visit youtube.com real quick, and I want to highlight something real quick. So let's inspect the elements, and for example, let's inspect this one. So in this HTML page that we're going to be uploading, for example, in youtube.com, when we visit YouTube, these images that we see here, these thumbnails, these are image files that has to sit in a server. And using the HTTP protocol, and as you can see in this image tag, the src attribute, we have an HTTPS link. So these media files have to sit somewhere, not the text. The text are going to be in a database, but these images, they have to sit somewhere. So they sit usually in a server that's 24/7 or a CDN network somewhere, but we are grabbing it from the server, that YouTube owns or something. Now, one thing about it is that, of course, again, it's a centralized system because everyone who visits youtube.com has to connect to these servers to grab these content. And there you go, that's the link. So what we're going to be doing though is imagine if this image tag, if the link, instead of HTTPS, it was BT for BitTorrent, or if it was ipfs, or if it was hypercore, or some other type of protocol that's peer-to-peer and not HTTP or HTTPS. That's essentially what we're going to be doing. Everything will stay the same except these src attribute links. These links will not be HTTPS, it will be BT, IPFS. So again, everything will stay the same that we're going to be uploading except the links. The links, we're going to be embedding peer-to-peer links inside of the HTML page. That's what we're going to be doing. And so let's get started. Let's go here. First, let's upload some dummy content. Now I'm using OBS, so the file viewer might not show because my system or OBS thinks that it's like a secondary window. It's a second window that I'm not tracking or capturing. So you're not going to be, I'm looking at the file viewer as we speak, going to upload some test files. But again, you most likely will not be seeing it. So alright, so yep, there you go. So just test files. And I'll go and copy that on my notepad. So that's IPFS. Now let's do the same thing. So dummy content for IPFS is done. Now let's do this for hypercore. Alright, so dummy content has been uploaded on hypercore as well. Now, now that's done, let me go ahead and change it to my notepad, and I'm going to show you what we're needing, what we're doing. Alright, so you should be seeing my notepad. Okay, so at the top here, that is IPFS content. These are the same things that I uploaded on the browser, and these are the data that it returned back to me. So the first one is IPFS. Now, what's important is that this is a JavaScript array of objects. If that doesn't make sense, if that does not make any sense, don't worry about it. It's unimportant for what we're doing today. So in this piece of data, both I uploaded two files in ipfs, and I uploaded again the same two files in hypercore. So in here there's two pieces of information that it returned back to me. The first one was for one file and the other one was for the other file. So now let me separate them. Okay, so this one is for the first file and this one is for the second file. Now, in each of these blocks of data, something got returned back to us is this link property. So in each file that we upload on the hybrid browser, on each file, if you upload 10 files, each file, the hybrid browser will return back to you a specific key or specific property that's something that we're going to need. It's this link property. This link is the actual link to the file. So ipfs : / this huge identifier here, that's a hash, and here's the file name. That is the full link to that specific file, and it's inside the link property. So let's take, oh well, I explained this part, so now let me explain the rest. So what we're going to be doing is we're going to take this link property, so both of the ipfs link properties that we got returned and the two link properties for the hypercore data that we uploaded. So we're going to take those link properties and we're going to embed them in a HTML file. So let me do that. Let me move this to my Notepad++. Okay, now you should be seeing Notepad++. Okay, so let's start with the first. So this is a just a basic HTML page. The title is test. It's not following the most it's not really up to standard. It's not following the most up-to-date HTML standards, but the browser should pick it up just fine. So the first is the image. So this is the first, we're on the ipfs block. This is the ipfs image, test image that I uploaded. So I'm just going to paste it here. There you go. And this is the audio file. So this is the second file that I uploaded on ipfs. It's the audio file. Okay, MP3. Now we're going to be on the hypercore block, and I'm going to upload the same test files, the hypercore links. So the first one is the image. Second one is the MP3. Okay, so this is what we're going to do. See, why I showed you that YouTube explanation, why we were on YouTube, I was explaining that inside of the YouTube elements, inside of the YouTube source, what happened is that we saw the elements, the image tag, and the image tag gave us a the image tag gave us a source attribute, and the source attribute was HTTPS links. But instead of, in this image tag, we're not seeing HTTP here. We're seeing a peer-to-peer ipfs link. That's really the only thing that we're changing. The only thing that we're doing here. So I'm going to copy this and just upload it right now. Move this to the browser. Okay. Now let me upload this. And if anyone gets technical, the YouTube page that we were on, of course, that's not the source. It's just the browser renders the source. Never know when you get one of those technical folks. All right. Okay. Okay, I just saved the HTML file. Now I'm gonna, so we use the ipfs protocol handler and we use the hypercore protocol handler. So I'm using ipfs and hyper to upload these files. Okay, so I'm using ipfs and hyper to upload these files. I'm using the ipfs network and the hyper network to hold those files. Uh, but what I want to do is, those are the media files. I guess I'm trying to explain that. ipfs and hypercore, they're holding my media files that I just uploaded, the image and the audio file. But how are we uploading a peer-to-peer website? What we're going to be doing is we're going to be doing the BitTorrent protocol handler. We're going to be uploading this to the BitTorrent network, and BitTorrent will be holding our HTML page, hence our peer-to-peer website. And let's see how that will work. So I'm going to make a mutable torrent. This will be a bep46 torrent. bep46 is an extension to upgrade the BitTorrent network to implement, mutable torrents, updatable torrents, whatever you want to call it. All right. So what we'll do is it will give us a public address. I'm uploading it right now, or a public key. I just call it address. All right. So here we go. Test.html. Remember, that is the file that holds our peer-to-peer links. It's got to wait a little until it responds with the links. All right, there you go. This is our data information about the torrent. The data we just uploaded, it created a torrent out of it. So now let me go over certain details here. So the address is the identifier for this torrent, for this peer-to-peer website. So that's the identifier, that's the address. So it's going to be bt colon slash slash, this identifier. This secret is very important. If you ever want to update this torrent, you're going to need that secret. You're going to need that secret key. That secret key, if you lose it, you're not going to be able to make updates anymore. Now, hybrid browser and the protocol handler that the hybrid browser uses actually uses a seed piece of data, seed string. This is the string. So this hybrid, I am I am the user of this hybrid browser right now, so I know this. Now I know this seed. So since I know it, I can just pop this in on the protocol handler on hybrid browser. I can just pop this in bt colon slash slash this thing right here, and then hybrid browser will know that I'm the owner and I can make updates to it. But another person will not know this seed. So the way to make updates to this address, to this public key, to this torrent, if you want to update it and change things, you either have to know the secret key right here, this big key, or you have to know the seed. So you either have to remember this secret key, or again, you have to remember the seed. And those are the two ways. And this secret key is derived from this seed. All right. So, and that's the info hash. So if you want to go to qBittorrent or transmission or uTorrent, whichever BitTorrent client that you use, you can use this info hash to download this specific torrent. All right. So, so now the main thing, just the link. Again, remember, every file that we upload to most of the protocol handlers on Hybrid, you're going to get this link property. That is the link to our website. As you can see, /test.html. That is the link to our website. This is really a torrent, but we're treating it, not only treating it, this is a website. This is something you can just copy and paste just like a regular URL, and you're going to view it as a website. So let's go ahead and do that. I already copied it. All right. 3, 2, 1. Bam. All right. So let me explain this real quick. So you're seeing content. They're seeing content right now. So what's happening is that, let me explain this. So this is the first IPFS block. So in this IPFS block, this is the first image, the first test file that we uploaded ourselves. This is coming from my computer because I'm the one who uploaded it. I'm the only one who has it right now. I haven't shared it. Now, why it's important, and let me back up here. Let me actually inspect it and show you. So remember, we were on YouTube, right? And we checked the image thumbnails. And when we checked the image tag on YouTube, the SRC attribute, attribute on the image tag was an HTTPS:// It was an HTTP link. And that link, we're using the HTTP protocol, it was a centralized fashion. So that link, on youtube.com, we grabbed it from YouTube server, from wherever it's coming from. Again, everyone who visits youtube.com has to talk to that server on a linear, centralized fashion. We are not getting the YouTube data from each other. Well, remember what we were talking about though. We're going to change that up, and now the image tag, the SRC attribute, it is not HTTPS, it's not HTTP, it is HTTP, it is IPFS. We are using the IPFS network we're interacting with the IPFS network, we're grabbing this piece of content from that network, and now we are using it on an HTML page just as if like a regular website. Again, this is coming from my computer though, because I have not shared this link with anyone, or this CID for anyone, the IPFS CID. So it doesn't mean that it's coming from my computer, but if I share this with someone else, they'll be able to do the exact same thing I did, and they would grab it from my computer. No server, my computer, and my room in my house. Pretend, this link, if this is a website that someone else uploaded, you just pretend say they shared a link with me, they shared their own website with me, gave me the link like this, I pasted it in here, pressed enter, went to it. What would happen is that I would be grabbing whatever links that's inside this HTML page, I would be grabbing it from their computer. So pretend this SRC attribute, this link that you see here, IPFS link that you see here, pretend it's a link of from coming from someone else. It would mean that when I go to this website, I would be pulling this image, or whatever file, whatever image, whatever other image they're uploading, I would grab it not from a server, but directly from their computer at their house or wherever they uploaded it, in their bedroom, wherever. So it's pretty cool. So again, not a lot of things changed. We didn't change anything. This is just an HTML page, just like any other HTML page. But what we did is we made the ability to grab content from peer-to-peer networks on an HTML page on a web browser. And so this is the audio file. So that's the audio file I uploaded to the IPFS network. Same thing, SRC, IPFS link. This is the hyper block. It's the hypercore block right there. This image was the same image, but I uploaded to the hypercore network, and this is the hypercore has a bigger link, so has to do that dot and make it smaller. Same thing, that's the audio file. They're both working, so everything works. So this is really it. This is a peer-to-peer website. I know, of course, this is simple. We're not creating Facebook here. This is very simple, but this is the foundation. This is the fundamentals. By doing this, I can have hundreds of these links and make it look like a nice website, but I'm just giving you an example of how to do all this, how it works, the things behind it, so I can recreate, how YouTube looks. The one thing I do want to talk about is there are certain things that are needed in the peer-to-peer world. So when we went to YouTube, let's go to YouTube right now. So when we go to YouTube, wait till it loads. There you go. So when we go to YouTube, these text right over here, these text, these titles, these text right here, well, that's really should be embedded in the HTML page, but these text right over here, that is, they don't hold that in a TXT file. That's too inefficient. Imagine if you have millions and billions of people visiting this website, visiting YouTube, and they just hold it in a TXT file. Like it wouldn't work. That's just not how it works, and it wouldn't work because that's way too inefficient. A lot of people would be, their equipment, their machines, their servers, it would have to open up a TXT file, read it, give it back to you, and millions of people visiting. So now it has to read it millions of times and everything. It just doesn't work. It's stupid. So where is this title held though? Where is this piece of text held? Where, in the bigger question is, where are the comments held? Each video has a comment board or, comment system. Where is those comments held? It's not held in a TXT file. It's not held in like an Excel file. It's not held in a file at all. It's held in a database. It's held in a MongoDB database, MySQL database, Neo4j, Cassandra, all those databases. It's held in a database. The database holds those comment, JSON data content, like these small text content. So now there's one thing though I guess there's one thing that's relevant to the P2P world when it comes to these types of small text data is that, they're small text data. One comment is small, but there's just a lot of comments. So they're big in that sense. They're in the aggregate, they are huge. Now, why I'm even talking about it is that how it's relevant is that in the P2P world, I have not found a formidable, a usable peer-to-peer database. I've not found one. I have found one. It was GunDB. I've worked with GunDB, but it's I've had issues with it. It wasn't practically working for me, and it uses WebRTC, um, which means that stability and all that is going to be stable. Um, the discovery features and how to paginate, whatever you want to call it, and how to do that. The way it works, it's just not as clear cut. It's just not as intuitive. Um, if there was something that the P2P world had that is just like MongoDB except peer-to-peer, great. That's great. So I am looking into alternatives to see if and what other kinds of projects are out there. What other kinds of things that we could use? Is there maybe something I miss? Maybe I missed cool project out there that just answers everything. But that is the next thing I'm looking for, is a peer-to-peer database, because if we had one, we've answered the file problem. We're pulling files from the peer-to-peer network, these images, videos, audio, any file, any static file that people want to consume, we can hold it and we can use it, and we can grab resources from that and put that on the web browser. We can do that. The problem is these text. What do we do about the text? Is there a peer-to-peer answer for that? Once we find one, then it becomes much more interesting, because we can recreate this entire homepage in a peer-to-peer fashion. And there was one other thing, which was streaming. I have not found a good way to do streaming, like streaming data in a peer-to-peer fashion. There are certain things I'm looking at right now. I just don't know if they're usable or how they would work and things like that. So, it's experimental times right now. The browser only gives you what it gives you. So you have to work with it. So the next best thing is just make a new browser. Now, hybrid browser and Agro browser uses Electron. A lot of folks might not like Electron. A lot of folks do like Electron. I don't know. You have to ask the people, but um, whatever. If it works, it works. Um, I'm also looking into maybe things that compete with Electron, maybe the alternatives to Electron that where you can make a browser, like bigger software like that. That way we wouldn't have to use Electron. But yeah, that's basically what's happening. So the developer of Hybrid, I'm not the developer of Hybrid. Um, I just like software, so I look into all of these things. Um, I dabble in it myself here and there, but I just look into these things and make small projects. I just found Hybrid interesting. I found Aggregore interesting. There's also the Sino browser. I was reading about that. One cool thing, Sino browser is about like privacy, not privacy, censorship. A browser to bypass censorship. Um, I think I talked about it before on Hybrid. It also uses the Tor. It has a Tor protocol handler, so a protocol handler. So if you want to use the Tor network, just keep Tor running in the background and it'll work with it. So either ways, just wanted to give you a demonstration on how all of this how all of this works. Haven't drunk enough water today, so kind of slow. But either case, yeah, thanks for watching the video and have a great day.